Okay, I'm going to talk to you about vaccination and the importance of vaccination, and also just review a little bit about the immune response. So if we think about what we've been doing, think about the idea that your immune system is stimulated by the antigens on bacteria or viruses, so that your lymphocytes produce antibodies and they destroy the pathogen by binding to them and causing the cell to burst or the virus to be clumped together and then eaten by macrophages. And then you create memory cells so that the next time you see the same pathogen with the same antigens on it, you will have a quicker response and therefore the microorganism will be killed. And so if we think about what that looks like on a graph, imagine you encountered a microbe here for the first time with a new antigen. It takes time, so there's a bit of a delay before your lymphocytes are stimulated and start producing antibodies. And then they'll start produce them. They won't produce very many, but there'll be enough to destroy the pathogen by clumping it together and getting it engulfed by phagocytes or whatever. But quite quickly afterwards, the level of antibodies will fall back down to a low level because they'll be got rid of out of your body. We don't keep antibodies floating around in your body all the time, but you will have made memory cells and they will be sitting stored in the lymph nodes and circulating around your body, waiting just in case you see the same pathogen again. Now, let's say a little bit of a time later, you see the same pathogen again with exactly the same antigen. Now this time, because you've got more memory cells this time than you had here, we didn't have very many lymphocytes that recognised the antigen there. Here we've got more memory cells, more lymphocytes that recognise that specific antigen, and they're going to reproduce much more rapidly. So you're going to have much less of a time delay, and you have a much steeper increase and a much higher response. Okay, so more antibodies produced more quickly and sooner. And also the level of antibodies stay higher in your blood for longer. And that means that the microorganism never has time to go through that incubation period and have enough bacteria or viruses to make you ill, because they're killed before they can. So the key thing is the pathogen is killed before it can reproduce, because you produce the antibodies more quickly. Those lymphocytes recognize that antigen more rapidly and produce the antibodies more quickly and in greater numbers. Okay, so we have this sort of sooner, faster, higher, longer response. And we're taking duration of the response, not only how long it takes to respond, it lasts for longer. Again, that's why you don't get ill. Now, if we think about vaccination, well, what are you doing? Well, what you're doing with vaccination is you're trying to make people do this part without getting sick. So you make them do what's called the primary immune response without them getting sick, so that if they see the real live pathogen, they do the secondary response. They've got memory cells. So all it basically is a modification of how do you become immune. So what vaccines have in them is they have either a live, attenuated, which means weakened, form of the microbe, or is dead or inactivated. Okay, so that might have been they've been heated up and killed. What's the important thing is that they will contain the antigen, and that stimulates your lymphocytes to produce lots more lymphocytes and produce the antibodies and memory cells, so that you then go through this response here. So basically, it's just vaccination is just a modification of the basic immune response. And lots of people are vaccinated now when they're very young to give you protection against lots of diseases like measles, mumps, rubella, polio, and tuberculosis. MMR is a key vaccine you need to be aware of. MMR stands for measles, mumps, and rubella. They're all viral infections. Okay, and you're given the MMR vaccine when you are young. Now, why is it important that we have vaccination? Well, the key thing is it makes people immune to the disease. It reduces the spread of disease, so we get fewer epidemics and maybe even pandemics. And it also protects people who can't get vaccination, because some people, because of their health, cannot be vaccinated. So actually everyone else around them being vaccinated creates what's called herd immunity that protects those that can't be vaccinated. But you have to have lots and lots and lots of people vaccinated in order for that to work. So if we look here, this is actually the percentage coverage of MMR on the bar chart, and then number of cases of measles. Now, here you can see we've got nearly 92% coverage, okay? And then in the late 90s, early 2000s, the levels of vaccination really dropped down. I mean, down to 80%. So it's not, remember the scale here, be careful on the scale, but the level of vaccination dropped quite low. And this is because somebody published a report which has now been widely discredited, saying that the MMR vaccine, the uptake of that was linked to the development of autism. It was widely discredited, it was utterly wrong, but it now persists. You've heard of anti-vaxxers on the internet. This sort of idea still persists. But you can see that when the level of vaccination falls, and we're talking below sort of 90-odd%, the number of cases of measles has started to go back up. Yes, we had a drop here, but if you look at the general trend, it's gone back up. Now, measles is a very, very dangerous disease for young children, and lots of diseases that we are vaccinated against are very dangerous and can cause severe illness and maybe even death. And because people don't see that anymore, they don't worry about it. They think, oh, well, look at the side effects, we look at the potential risks, and that's why levels of vaccination can fall, and why certain viewpoints, especially with the advent of social media and Karen on Facebook or Bill on Facebook says this, they believe that, it can cause these effects. Okay, so you can see this effect here. So vaccination levels high, very few cases, so very little impact of this disease, very few people getting ill at all. Okay, when the vaccination levels fall, we get these increases because we've got more people who can carry it and more people who can spread it. Okay, here's another example here. This is a story about the quality of this graph. It's my printer. You can see we've got case of whooping cough and vaccination. Okay, so you can see here in the 1940s and 50s, we didn't have vaccination against whooping cough, and we had quite a large number of cases, in the thousands or 150,000 a year or more. Okay, and actually we had quite high death rates in the early 1940s. Okay, think about maybe that was around the war, healthcare and things like that. Maybe healthcare got better here, so people weren't dying, but there were still lots of cases which could have had lots and lots of side effects. As soon as vaccination starts, the number of cases falls and stays pretty low. But then again, there was another scare about the vaccine. Levels really dropped to 30%, and again, the case of whooping cough come back again. And then as soon as the vaccination level went back up, it goes back down and it stays low. And that's what's really important. And the key thing about vaccination is some diseases have been completely eradicated. So things like smallpox was entirely eradicated by a massive global vaccination program. So hopefully that gives you a bit of information about vaccination. Thanks.